Hello, everyone. My name is Vishnu Kumar, and I am an industrial engineering graduate student at Penn State. Today, I'll be presenting my research titled Machine Learning-Based Suicide Prediction and Development of Suicide Vulnerability Index for U.S. Counties. Suicide has been a growing public health concern in the U.S., recording 35% increase from 1999 to 2008. You can see from the graph here, the suicide rates have been constantly increasing over the last 20 years. According to the CDC, suicide is constantly listed among the top 5 leading causes of the death in the US for selected age groups, according to the statistics obtained in 2019. Numerous strategies and resources have been identified and developed in the past to control and prevent suicide. However, most of these interventions are for large geographic areas at either the state or national level, and hence might not necessarily reflect the trends of a particular region or county. To bridge this gap, this work explores the trends and geographical distribution of suicides across US counties. Next, this work develops a machine learning-based model to predict county-level suicides. Based on the output from the prediction model, a novel suicide vulnerability index is then developed. The aim of the SVI is to detect US counties vulnerable to high suicide rates and thus boost targeted and localized suicide control and prevention efforts. To begin with, this work looks into the suicide distribution across all the US counties here. The figure here shows a map which represents each and every county in the United States along with their average suicide rates taken across the 10-year period between 2010 and 2019. As we can observe from this map here, we notice that the regions in the West Coast, the regions in the East Coast, and some of the regions in the state of Florida seem to have higher average suicide rates for the last 10 years. And this is denoted by the darker shade of the color. The work then moves over to create the suicide prediction model. Now, to build this suicide prediction model, this work uses publicly available data to extract 17 county-level factors as shown in this table here. The data is obtained for all the 3,140 counties. It was then used to train a machine learning-based prediction model, which is XGBoost regressor in this case. This model was found to perform well with high accuracy, as we can see from the R-square value here. Now, we use this 17 county features in this model, and it can be argued that not all the 17 features had an equal contribution to the output. Some of the features here might have contributed more, and some of the features might have had less impact on the output itself. So to see the impact of each and every feature in the model, we used what is known as a SHAP plot. This figure here shows the SHAP plot. So it basically gives two pieces of information. One, the features that are important for the prediction, which is given by the order listed here, and two, how each feature affects the prediction, which is given by the color coding here. This work, we took the top 5 important features that were predicted by the SHAP plot, and these top 5 features were then used to create the novel suicide vulnerability index, SVI. So SVI is essentially a number between 0 and 1. And it basically says that as the SVI value increases from 0 all the way up to 1, the vulnerability of a region to suicide increases. So the regions with a SVI value equal to 0 is less prone to suicide. And those regions which have a SVI value close to 1 are more prone to suicide. The SVI itself is computed using a simple formula that is shown here. Each term in this formula corresponds to each of the 5 important features that were identified from the SHAP plot. So using this SVI values, we then recreated this map, which shows the SVI distribution across the entire country. So the regions with a low SVI values have a light shade, and the regions with the high SVI values have a darker shade in color. As you can observe, the counties in the West Coast, the East Coast, and some part of Florida seem to have higher SVI values, which means that they are more prone to suicides. So to conclude, this work developed a machine learning-based prediction model to predict suicide, and it was found to perform with high accuracy. The machine learning-based prediction model was then used to extract the SHAP values that was used to identify those features that were important in the model. Using the top 5 important features, this work developed a novel SVI or suicide vulnerability index that could identify counties that were prone to high suicide rates. Having such an index can prove to be very useful in effectively allocating resources and boosting targeted suicide prevention and control efforts. I conclude my presentation, and thank you so much for your attention, and I'll be happy to answer any questions you might have.